Hello, my name's Ainsley Strang.
And I'm Katrisse Mendoza, and today we're presenting Fibonacci sequence and golden ratio.
The golden ratio is a concept that has been around since the ancient Greeks, whose involvement can be traced back to Plato's description of the Platonic solids, which are shapes that define our world. Plato believes that the last of the Platonic solids was the dodecahedron, an assemblage of 12 pentagons intended to represent the shape of the universe. These pentagons follow the divine ratio and is believed to be the inspiration for Lucid's extreme and mean ratio, the first explicit definition of the golden ratio. This number, now known as phi, holds many special properties, including being the only number whose square is exactly one greater than itself and whose reciprocal is exactly one less. To calculate phi, if we were to divide a line segment into two parts, the ratio of the length of the longer part, part A, and the shorter part, part B, needs to equal the ratio of the sum of A and B to A, as shown in the figure. Using this information, we can calculate the golden rectangle. First, as shown in step 1, we draw a line from point B to the center of line segment CD. Then, using the angle created by this triangle, we would draw an arc using the same angle starting from point B, as shown in steps 2 and 3. Then, if we continue this arc, it will eventually create a spiraling structure. This spiral, has been found to actually represent the Fibonacci sequence. The Fibonacci sequence is an infinite series of numbers who is defined as f of n plus f of the next term. Ultimately, we'd end up with the values 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on, whose sequence's ratio between the previous two terms is constantly approaching 5, as shown in the chart. This defined portion actually has many functions outside of mathematics and can be applied to the world of biopsychology. In a study titled Psi in Psychology, Physiology, and Biomechanics, the golden ratio between myth and science, the authors studied the proportions between a subject's stride compared to their stance. Ultimately, the authors concluded that in a healthy subject, the ratio between the stance and swing durations is equal to the ratio between the stride and stance durations, and both equal phi. In addition to this, they found that in patients that were psychologically unwell, such as those who suffered from Parkinson's disease, that these ratios were not found, highlighting the importance of our brain in the perception of these ratios and in our health.
Of course, there are many people who discredit this theory of application of the golden ratio, calling it a myth. However, it is undeniable that there are at least some correlations that divine proportions in the Fibonacci sequence have in our world. For example, the shape created by the Fibonacci sequence is reminiscent of a chambered nautilus shell. They are known to have complex body plans, as the chambers are created in response to their weight to maintain neutral buoyancy. While it is true that sometimes living things may not perfectly correlate to the golden ratio, it is nearly perfect, an adaptation that is undoubtedly related to the significance of the Fibonacci sequence in our world. Leonardo Pisano, also known as Fibonacci, was the first to detail the standard of growth for a population of rabbits utilizing the Fibonacci sequence. This is an idealized population with the following conditions. First, a single pair of newborn male and female rabbits are put in a field. Second, rabbits can mate once they are 1 month old. And 3, rabbits never die and mating always produces a new pair. By knowing the perfect model for the repopulation of different species, scientists are able to determine the pitfalls of their individual adaptations and environments, giving us deeper insight into the ecosystems around us. The Fibonacci sequence is also applicable to plants such as sunflowers. Specifically, the seeds or florets of the sunflowers growing in circular arcs are representative of the golden rectangle proven by divine proportions. In relation to biology, this occurs naturally because of the presence of auxin, specifically indole 3 acidic acid. The plant hormone affects the plant's development and the formation of disc florets. The golden ratio is found when the angle created by the floret reaches the golden angle of roughly 137.5 degrees, and the flower head gets packed most densely and evenly. Thus, the divine proportion is reached when the sunflower obtains substantial growth. As auxin is more present in areas with less light, this can affect the auxiliary buds due to their root to shoot biomass, affecting the overall yield of a flowering plant. This can be represented by stabilizing selection if the sunflowers with disc florets that correspond to the golden angle have an intermediate phenotype characterized by phi, the golden ratio, and have the highest fitness as shown on the very right. This shape is also thought to have guided many architectural and artistic feats, such as Leonardo da Vinci's Mona Lisa and the Sacrament of the Last Supper, the Parthenon in Athens, as well as in renowned paintings and buildings throughout the world.
Professor of Mechanical Engineering at Duke University, Adrian Bennon, predicts that the reason our brain tends to appreciate art pieces such as these is because of their use of the golden ratio. He explains that it is well known that the eyes take in information more efficiently when they scan side to side, as opposed to up and down, making the divine ratio the best proportion in order to transfer information to the brain. In fact, viewing these golden ratios sets off the reward center of our brain, releasing dopamine and making us more likely to view the paintings that golden that follows the golden ratio in a positive light. While some scholars may argue that the use of the golden rectangle in these works and many others is simply by coincidence, it may have something to do with how our brains relay information. As explained before, perceiving the golden ratio activates our brain's dopamine systems, making us want to view the ratio again and again. This is similar to how we've been conditioned to reach for our phones, as doing so releases dopamine in our brains. This in turn can make artists and architects more susceptible to create using the ratio, even if unintended, because when they do so, they are rewarded by the brain. Here are works cited, mostly consisting of research papers and commentaries on the Fibonacci sequence. Thank you so much for listening to our presentation.